Hey everyone, Steven here, and I've been experimenting a lot with a local LLM setup lately, and I thought I would share a little bit of what I've been learning about that process because there are a lot of new terms to learn, there's a lot of new vocabulary, and they all are pretty important actually for getting the tuning right for your performance. So let's talk a little bit about some of those. So the first thing you'll notice when you download LM Studio and you go into their marketplace to download models is that a lot of different companies are putting models out there. So that's probably the first decision you should make. Which brand of model do you want? Which line? Do you want to go with Google's Gemma open model line? Or do you want to go with something more like Qwen, which is what I've been using lately? 3.6 and 3.8 just came out last week. So that'll be the first choice you have to make. And then within that, you'll see a lot of different parameters and choices within the models themselves. So, just as a general rule of thumb, you should probably look for the latest release version of any given model. So 3.8 is the newest Qwen release, and it just came out last week. So as soon as it came out, I looked into switching to it. Then once you've chosen the version, you should look at the number of parameters. So this might be the single most important detail about an LLM, a large language model. This is how many parameters are being used in the decision to generate the word. And if you ever took a class like econometrics or statistics in college, you probably had to do an exercise where you fit data to a line or a curve. And it's actually the same principle here, just expanded out by many magnitudes of, quantity, I guess, because, I'm thinking back when I did this for my economics bachelor's degree, I think I created a model that had about 15 parameters, maybe even less than that. And some of the models that we're looking at are multiple billions of parameters, which is partly why they've been working so effectively in real world applications. You can imagine that there are 15, in my scenario, 15 decision points that can affect the outcome. And with these models, there are many billions of them. So the more parameters you can fit in a model, the better the results will be. Now that means that the larger parameter models are often larger in size too. So that's why when you go to download some of these, you're going to see 20 gigabytes, 30 gigabytes, and more. This is where RAM size really comes into consideration, because in order for these to work most effectively, they need to be able to load the whole model into RAM. And your local hardware RAM will set an upper bound for how large the model can be, because if you can't offload it, you'll only be offloading a partial amount and it won't perform quite the same way. So keep an eye out for parameters. More parameters are better, but you will be downloading a larger model as a result of picking a higher parameter model.